All right, guys, welcome to the double angle formulas. So again, we're going to have double angle formulas for sine, cosine, and tangent, okay? So we're talking about doubling an angle, okay? So the sine of 2 theta is going to be equal to 2 cosine theta sine theta. Cosine, you get 3 options here, so you can pick either of the 3. So you get cosine of 2 theta can be equal to cosine squared theta minus sine squared theta. You can use 2 cosine squared theta minus 1, or you can use 1 minus 2 sine squared theta. Any of those 3 you can use when dealing with cosine of 2 theta. Lastly, we have tangent of 2 theta. The tangent of 2 theta is equal to 2 tan theta divided by 1 minus tan squared of theta. So what we're going to do is use these 3 angle formulas, okay, and simplify expressions. In our first example, we just show one of the proofs and how we actually derive these. And we actually use the sum and difference formulas, or difference formulas. So, show that sine of 2 theta is actually equal to 2 cosine theta sine theta. So, I'm going to start on the left side, sine of 2 theta, and I'm going to rewrite that. Well, 2 is equal to 1 plus 1. If I have 2 theta, that's just equal to theta plus theta. And so now I'm going to use that sum formula from the previous video. So I go ahead and apply that sum rule. Okay, so I get sine theta cosine theta plus sine theta cosine theta. Look, they're the exact same term. I have 2 of them, so I get 2 cosine theta sine theta. I can switch their order to match this because of the commutative property of multiplication. So there's my proof. So I just showed this. I can show these double angles by using the sum and difference formula from the previous video. Now, in our first example, we're given that tangent theta is equal to 4 over negative 3. Find the following. We want to find sine of 2 theta, and we want to find cosine of 2 theta. In these examples, we have to go back to our reference triangle. So we're going to create a reference triangle to find the hypotenuse. So remember, this value is, tangent is opposite over adjacent. It's the y value over the x value. We need the r value here. So here's my reference triangle, negative 3 and 4. So it's important to realize that the angle I'm looking at here is between pi over 2 and pi. I'm in the second quadrant. So between pi over 2 and pi is the angle measure. Okay? So to find the missing radius, I have to use Pythagorean's theorem, which I've shown here. So we have negative 3 squared plus 4 squared equals r squared. So that's 9 and 16 equals r squared. 25 equals r squared. And so r equals 5. So this should be review. So now we've got our reference triangle. We have x, y, and we have our r value. Now I can use that to find my 2 double angles. Now, so we're going to find the exact values where x equals negative 3, y equals 4, and r equals 5. I wrote those 3 values. So we know that sine of 2 theta is equal to 2 cosine theta sine theta. So that's going to be equal to 2. Now cosine is the adjacent over hypotenuse, Sine is the opposite over the hypotenuse, so that's 4 over 5. So I go ahead and substitute those values in and simplify, and I get negative 24 over 25. If I want cosine of 2 theta, I'm going to use 2 cosine squared theta minus 1. Remember, I have a few choices here. I chose this one. Cosine, remember, is negative 3/5. So I plug that in and I get 9/25. So 2 times 9/25 minus, I converted 1 to 25 over 25, and I end up with negative 7/25. Now, these are double angles. So recall that if you were in the angle, the original angle is between pi over 2 and pi. Now, if it was the double angle, it would be, if I multiplied everything by 2, my new angle has to be somewhere between pi and 2 pi. But since both my values of cosine and sine are negative, that means they have to be in quadrant 3. So my angle measure would be somewhere between pi and 3 pi over 2. Okay? So just be very careful. So I put here, notice how both sine and cosine are less than 0. So the double angle would be in quadrant 3. So we had all this opportunity here to say, well, our double angle's got to be somewhere between pi and 2 pi, but we know it's going to be in quadrant 3 because both sine and cosine are negative. In our last example, we're going to be doing really the same thing. And we're going to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So if sine theta equals 5/13ths, and it's going to lie in the second quadrant, find the exact value of the following. So here's what we're looking for. Those three double angles. Sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So again, draw the reference triangle. Okay, so here's my reference triangle. Notice it's going to be a -12, 5, and 13. I found that by using Pythagoras theorem. This is a little different. This time I knew the radius because I know my sine value, the opposite over hypotenuse. There's my angle, opposite over hypotenuse. Notice how here x is 12, but on the coordinate plane it's going to be negative because it's a direction. So here are my three values, -12, 5, and 13. I can now go ahead and find those values. So here's what I did. I went ahead and I said when x equals -12, y equals 5, r equals 13, sine of 2 theta is equal to 2 times cosine theta sine theta. Here's my substitution. Okay, cosine is the adjacent over hypotenuse, -12/13. Sine is what they gave us, which was 5/13. And when I multiply that across, I get -120 over 169. I use the same value in part B to find cosine 2 theta that I did in the previous example. 2 cosine squared theta minus 1. Okay, so I know that cosine is -12 over 13. I square that. So I have 2 times 144 over 169, which is 288 over 169. And then 1 is the same as 169 over 169. I'm left with 119 over 169. Now, the last one I kind of not cheat a little bit, but I used what I had. I have a formula for tangent of 2 theta, but I know that tangent of 2 theta is going to be equal to these two things. Sine 2 theta over cosine 2 theta. So I just took my two previous answers, and I have sine theta divided by cosine 2 theta. When I divide a fraction, I flip it and multiply by its reciprocal, and I did that here. My 169's become 1, so I'm left with -120 over 119. So that's how we can use the double angle formulas. If you guys have any questions or comments, let me know, or you can type them below, and we'll see you next time.